And so from last meeting, we have answered questions 1 and 2, right? Is the average age of the Titanic passengers equal to 30? Actually, I still save the solutions. So just a recap, these are the 7 steps when conducting hypothesis tests. This is the same for every hypothesis test we're gonna discuss. Okay. Of course, the calculation steps 4, 5, 6, and 7. You're gonna do it with the aid of Excel. That's the point of the course, right? You're gonna use software, statistical packages, right? But step 1 is very crucial, formulating null and alternative hypothesis. That's why we're still discussing this. Kasi if you reject HO and you have the wrong HO, you're gonna have the wrong answer, right? So let's just summarize the first one. Number 1, HO mu is equal to 30 versus HA mu not equal to 30. All right. And then we conducted a z-test for 1 mean. Let me check later if I've already uploaded these slides, but you have a guide right here, and I left a guide. So these are the test statistics. For 1 mean, you can use a z-test or a t-test. You use a z-test when sigma is known. You use a t-test when sigma is unknown. We have also discussed from last meeting na a t-test or a z-test is just is approximately approached by the t-test, right? When n is very large, usually from senior high, you're discussing n is greater than 30. But it's actually when n is very large, it's kind of subjective, or as n approaches infinity. Then we use a z-test. We can use a z-test, or basically the 2 tests right here yield the same thing, yield the same numbers. Yung mga critical values, the test statistics, they will yield the same values when n is large. Okay, so I think we've mentioned that last time. So next, number two is, does age differ among survivors and those who did not survive? So from last meeting, I remember si Javi pa nga sumagot nito, I think. So the mean for the survivors is equal to the mean of the non-survivors. That's H null. HA is mu S not equal to mu NS. Or alternatively, we can write this as equal to 0 yung difference. Mu S minus mu NS not equal to 0 yung difference. All right. So these two are the same. Just to be clear, these two are the same. Okay. And then from last meeting, again, recap lang ulit. We use this guide. We have 4 cases when we deal with problems regarding 2 means. So is it going to be a z-test, a pooled variance t-test, separate variance t-test, or a paired t-test? And then we eliminate one after the other. First, it's not involving dependent samples. Dependent samples are the ones with the correspondence with each other. So for example, yun nga, I'm comparing stat 101 and stat 201 and stat 203 grades for your class. So nandyan si person A, person B, person C, person D. You have A has a stat 201 score, stat 203 score. So there's a correspondence between the two values. Parehas silang kay person A. That's when you do a paired t-test. But for the Titanic, there's no pairing naman among survivors and those who did not survive, right? So we're gonna eliminate case 4. Also, sigma 1 and sigma 2 are not known. Actually, most of the time, since you're dealing with data sets na samples lang naman, take note, it's a sample of 1,309 passengers at the Titanic dataset. Sample lang. So you don't really know sigma 1 and sigma 2. So we eliminate this as well. So from last meeting, we decided either case 2 or case 3. Is it a pooled variance t-test or a separate variance t-test? I think we have the recording naman, so you can go back into it. But the summary is, we're testing for the variances. Can we assume they are equal? If we can, then we use a pooled variance t-test. Are they assumed to be unequal? If yes, unequal sila, separate variance t-test, right? And we did it using Excel, using Statistica, both, as far as I recall. So, all right. So, at the end of the day, I think we arrived at the conclusion that we're going to use t-test, separate variance t-test. since when we check the variances for survivors and non-survivors, they're significantly different. Malinaw naman yun from last meeting. Just want to ask, okay yung mga procedures, ha? Okay. Paki-chat na lang. Please do chat if you have some questions or maybe something na confusing. But let's go to number 3. So these numbers 3 and 4 is they're actually part of what I let you watch or what I let you read from the independent learning week. Sana masagot na ito. Number 3, is there a significant difference in the ages across different passenger classes? So now let's answer it the same way. What will be the null and alternative hypothesis first? Anyone? And hintayin ko sa inyo yung galing.
Excuse me?
Yes.
So the age null is mu of age of first class equals mus of 2 equals mus of 3. Then the HA will be at least one of them is different.
Okay, so I hope this is clear with everyone, ha? So in this case, we're comparing 3 means. So actually, these slides, they don't capture that scenario na. Kasi this is only for 2 populations and 1 population, these slides. So for this case, ano yung gamitin natin? What's the appropriate statistical method or test? Anyone? Nabasa na yan, ha?
Chi-square ba, sir?
Hindi eh. Ang chi-square kasi, ano bang nakuha nyo sa chi-square from the videos? Anong kina-compare? Sa chi-square kasi kina-compare niya ay multiple proportions. Basically, the data that you have, if you can imagine it, they are of the form of counts. For example, number 4, chi-square yan. Kasi what will happen is you're gonna have a table ng males, females. Ayan, nakikita ko naman yung mga chat nyo. Ano ba talaga? Sagutin ko lang yung chi-square, ha. Survivor, non-survivor. So you're gonna have counts. How many males did survive? How many females did survive? How many males did not survive? How many females did not survive? So if you have those types of data, counts, chi-square yan. So since here we're dealing with ages eh. So we have a variable age, numerical. So averages, significant difference in ages as measured by averages. So when measuring, when comparing multiple means, just so we can generalize, we use an ANOVA, one-way ANOVA in particular. Sige, tanongin ko lang kayo, I'm gonna ask you a question. What about two-way ANOVA? Diniscuss nyo from previous stat classes. Two-way ANOVA. Hello? Hindi ko pala nakikita kung nagla-like kayo. Sige pa ulit kung sumagot man kayo. Hello?
Sir, what's the question again?
Okay. Did you guys study two-way ANOVA back in senior high, back in Stat 101 if you did take it?
I think so, yes.
Okay, two-way. The others, what about you?
No sa stat 101 or 201. No.
Okay. Sige, so sige, yun lang. One of each possible answer. Sige. I'm just gonna assume you didn't. So let's not go into two-way ANOVA. Besides your stat majors, you're gonna do a lot more ANOVAs. So one-way ANOVA lang. Sige, okay na yan. Gist of the course naman is to use the software. All right, so here, so one-way ANOVA is the one we're gonna use. Meron mong sasalita? May sabihin kayo? Okay, sige. Let me proceed. So that's it, one-way ANOVA. What about for number 4? For number 4, we know it's a chi-square test, but how do we formulate the null and alternative hypothesis? Anyone? HO and HA pa rin eh. Can't leave this with the software. Kahit balikan nyo na lang yung mga videos or yung reading.
Sir,
Sino ito?
Rani po.
Sige, Rani.
Sir, yun po ba yung survival rate and gender are associated or not po?
Okay, so sige. Saan mo nakita yan? Sa readings?
Yes, sir.
Okay, sige. Survival. That's correct, by the way. Kailangan nata nag-stat 101 pala kayo. Talaga. Even if yung mga exempted siguro. Marami exempted ata sa inyo, di ba? Ayan, pero yun, for refresher lang. Survival rate. Ang dali nga, naubusan ako ng space. Wait lang. Rani, tawagin ulit kita maya-maya. Pakisabi yung sinabi mo. Maya-maya. Wait lang. Ano, Rani? Number 4? Ano yung HO?
Survival rate and gender are not associated po.
Gender, sex, okay. Are not associated.
Yes po.
Okay. And then dito, HA, associated.
Yes po.
Okay. And sex are associated. So that's correct. Okay. So moving back, balik lang tayo saglit dun sa ANOVA example. The first one, the null hypothesis, how are we gonna interpret this? Can we write it in words instead of statistical terms? Actually, yes. Paano ba ito? No significant difference or no effect on ages across passenger classes. P class na lang So that's the same, right? No significant difference on of ages across different passenger classes. So that's how you put it into words. Then at least one is different, particularly at least one mu I, and at least one average is different. And we can write it as there's a significant difference. At least one is significantly different. Nababawasan kayo? Oh my God. Okay. Ayan, so going back dito, we can also write this in statistical terms. Kaya tama yung sabi ni Rani kasi we can also write it as proportion of survivors for males equal to the proportion of survivors for females, right? What do you think? Is it the same? Survival rate and sex are not associated. Equal survival rates for males and females. Same, di ba? Okay. So same sila. So for the other one, PM is not equal to PF. So yun, it's basically a test for two proportions. And what we do is a chi-square test. Generalize na lang natin, chi-square test. So this is a chi-square test.
Qualitative.
Hmm?
Oh, sorry, I forgot to mute, but I was just noting myself that's the data is qualitative, survival rate and sex.
Yun, precisely, sabi rin ni Javi na yun. Qualitative siya, survival rate and sex yung variables. Kapag quali sila parehas, chi-square yan, for sure. You're gonna deal with frequencies instead of raw values of the variables. So, okay na. So, we have these two. Let's perform it sa Excel na. Excel na natin to. Paki-note yung HO and HA for number 3 and number 4. We skip every other step, yung mga yan. Nasagot naman natin yung number 1, di ba? Nasagot din natin si step 2. And then let's assume 0.05 alpha always. Then we skip steps 4 and 5, yung mga manual computations, since we already have Excel or Statistica. Okay. So, balik lang ako sa laptop saglit. Ayan. So we have the Titanic dataset. Ano yung question sa number 3? Ano yung sabi ko? Ano yung question sa number 3? Wait lang. Is there a significant difference in ages across different passenger classes? Is there a significant difference in ages across P class na lang? Excuse me. Okay, so how do we answer this? Again, we know it's an ANOVA, right? So data analysis tool pack. And then may one-way ANOVA dyan. Nasaan na ba yun? ANOVA single factor. An ANOVA, kaya siya tinawag na one-way ANOVA since one way, one factor ANOVA. So we choose that input range. Tingnan natin ha, let's see. Passenger class, what are the variables involved? Age and passenger class, right? Nagma-match ba? Doesn't match, right? You're only given one input range. So what does Excel expect? Excel expects them to be grouped. So yun, that's the problem with Excel. And actually Statistic as well. It only accepts specific data structures. So we involve P class and age. We have to restructure them. Kailangan ganito yung itsura. 1, 2, 3. Ano ba yan? 1, 2, 3. And then the ages below. So gawin natin yun. Medyo diskartehan talaga natin. We have to make it happen. So how do we do that? Ay, nako. We can use filters, of course. If you want to do it brute force, we filter those who are passenger class 1. Let's put column headings na dito, 1, 2, and 3. Or class 1, class 2, class 3. And demonstration lang naman tayo ngayon. So we're gonna select all ages. Ito na naman tayo. Ano nga ba yung tinuro nyo sa akin last time? Lahat na lang, no? The whole column. Hindi siya gagana ngayon. My God. Or, scroll down. Konti lang naman siya. So, copy the whole thing. Oops. Sorry, Class 2, manual. Copy everything. Yan na ba lahat? Ayan. Hindi ko pa pin-repair, no? Okay lang yan. Class 3. Katulog kayo na ito eh. H. Hanggang 1309 na ito. Wait lang. Daming missing kasi. You can always filter out the missing ones as well. Hindi ko naisip yun. And so, time-saving tips lang kasi you're just given 1.5 hours sa exam. So here, data should be structured this way for Excel to accept it. So data, let's use ANOVA na, single factor. Input range will be everything. Ito na naman. Sige, pwede na siguro to. The whole columns, whole 3 columns. Group by columns. Labels in the first row, alpha is 0.05. Then we have this. Okay, so this is yet another part of the video or the readings. The results for ANOVA is given by this ANOVA table. So the ANOVA table, SS stands for sum of squares. DF stands for degrees of freedom. MS for mean squares. F for test statistic. And this is the p-value. As we mentioned last time, we're gonna rely on the p-value a lot when using software. So okay, what's the main conclusion here? So p-value is very small. That's 1.8 times 10 to the negative 43. You remember our HO and HA. So H null is mu1 is equal to mu2 is equal to mu3. HA is at least one mu is different. Or
Excuse me,
yes.
go on.
Bakit? Okay. Alternatively, this can be written as age does not vary significantly across passenger class. This one can be written as at least one passenger class has a significantly different mean age. Yan. Okay. So yun, given this p-value, 1.8 times 10 to the negative 43, what will be our decision and conclusion? So same steps
Excuse
naman,
me.
decision, conclusion. Yes, ano?
So our p-value is 1.8 times 10 to the negative 43, and also our f value is greater than our f critical value. So our decision is to reject H null. So at least we can conclude that at least one passenger class has a significantly different mean age.
Has a significantly different mean age. So that's it. So that's how it works. All right. Guys, have any questions dito? So at least one passenger class has significantly different mean age. Okay. Can you guess what passenger class is it, or are they significantly different from each other? How do we answer those questions? Well, we have the so-called post hoc tests, but I think we're gonna do it once we go to R na, kasi wala siya sa Excel, wala siya, meron naman ata sa Statistica, pero hindi kayang gawin eh. Baka meron pa ba sa inyong wala pang Statistica? Anyone knows Statistica yet?
I don't have yet. I'm still having problems. I responded to the IT department and I cross-copied you.
Yeah, I saw the emails. Hopefully they respond soon kasi they respond really late, right? Si Alain, meron ka na? Statistica?
Wala pa rin, sir.
Okay, so talagang Excel. So we're gonna be stuck with Excel. So every question must be answerable by Excel. So no post-hoc tests yet, but the question is open, ha? We will answer it sometime using SAS. What age is significantly different from what passenger class has a significantly different age from each other? So if you can see right here, ito yung 3 passenger classes. You have descriptives as well. So 39 is the average age for class 1, 29 for class 2, 24 for class 3. So I think it's clear. Class 1 passengers tend to be a bit older as compared to the others, right? So that's why the descriptives and the inferential, they support each other. So ano bang what possible way can we visualize this? Di ba meron tayong mga tinatawag na box plots? We used box plots back then. So we can use box plots again. Wait lang Ano ba yan? Daming passenger class 3 oh. Napakita nyo naman from descriptives, right? Bakit ayaw na talaga mag-straight? Sige na nga, all columns na lang. We can use box plots to compare them. Sige, recommended charts, all charts, box and whiskers. So here are the ages. As you can see, they're different. The average ages are all different across the 3 different passenger classes. But apparently, we confirm na inferential statistics work that way. This difference, yung number 1 versus number 2 versus number 3, significant siya, statistically significant, which means that we can generalize it for all Titanic passengers, the whole population. We can safely assume that. So clear naman tayo dito. So at least you're gonna have to know how to palabasin itong ANOVA table. You have to know how to create this using the data analysis tool pack. And then here, you have to know how to interpret them. Ganun lang naman talaga. So reject HO, we can conclude that at least one P class has a significantly different mean age. So okay na. So next tayo, next. So next we're gonna use the we're gonna answer number 4. So number 4, the question in number 4, let's just clear the filters. Number 4 is, does the survival rate differ between males and females? Okay. So survival rate differ between males and females. Okay. So wait lang. Let's see. We said na may chi-square test. We're gonna involve the variable sex and the variable survived. Kasi yun naman, survival rate, the difference between sexes. So meron ba siya dito? Let's see. So the problem with Excel, limited na naman siya. So it doesn't have a chi-square test. So we're gonna have to do it a bit manually if you're gonna use Excel lang. Later on, I'm gonna show you how to do them all on Statistica. Medyo mas madali. But let's see. So how do we conduct a chi-square test? So first off, we write down the null and alternative hypothesis, of course. So number 1, nasagot na natin to kanina, HOI at P proportion ng males is equal to proportion for females. P proportion being survival rate, proportion of survivors. HA P of M sub M not equal. Yung notation ko not equal na ganun. Parang for programming. So P underscore F. So number 2, it's a chi-square test. Number 3, we use alpha equals 0.05. Number 4, critical value. Let's skip it first. Number 5, test statistic. I hope ito medyo clear from the videos, but the test statistic from the chi-square test, chi-square, it's going to be given by, wait lang, this formula. Summation of O sub I minus E sub I over E sub I. Naka-square pala yung numerator. Okay, so how do we do that? Of course, we're gonna have two tables, the observed frequencies and the expected frequencies. Okay. So the observed frequencies, basically, we're just gonna cross-tabulate. So ito yung survivors, serve na lang, and serve yung non-survivors. Ito yung males, ito yung females. And the same thing for the expected observations. Okay? So we filled them up. So ang tanong ko ngayon sa inyo, how did you do yung mga cross tabulations from your Titanic presentation? Pivot tables yun. Hello? Remember?
Yes, sir.
Sige nga, hindi kasi ako nag-pivot table. Paano siya gawin? Insert pivot table. Ay, kailangan ko i-highlight lahat, no? Guide nyo ako. Kasi hindi ko kayang bilangin to manually. Can't count them manually. This is really easy sa statistika ngayon. Arte. Everything. Insert pivot table. Yan. So, ano to? Sex and survive. Ayun, wait lang. Paano ginagawa? Yun, pakitulungan naman ako.
Sir, dapat po ata count.
Ayun, count. Sige, thank you. Count. Oo nga, ayun. Okay na, di ba? Thank you, thank you, thank you. So, we fill them up. So, yun, one step lang siya. Sorry ayoko nung pivot tables. So, yan. So, we can write the totals as well. Row totals and then column totals. And then grand total. Sum ng any. Pwedeng yung columns, pwedeng yung rows. Boldface natin sila. Okay. And then we copy them right here. So ito yung procedure ha. Okay, copy them values. Okay. Medyo minamanual natin siya since Excel doesn't have it. It's supposed to be a part of the basic hypothesis test talaga. So how do we fill up? Observed frequencies are, as the name suggests, observed frequencies. The observed number of male survivors, observed number of female survivors, and so on. What are the expected numbers? So the expected numbers is what do you expect under HO? So if the proportion or if the survival rate is the same for males and females, what would you expect will be the contents of this cell? So that's how you're gonna interpret that. So and it's computed as row total times column total all over grand total. So sa Excel, it's row total 466. If you're familiar with yung F4 key, pwede nyo gawin yan. The dollar sign in Excel, it means you're fixing that. So let's say here, Q18, if I drag it sa left, it's gonna be R18. If I'm gonna drag it downwards, it's gonna be 466 as well. You're fixing it at 18. Parang ganun. Gagawin natin this one times this one all over this one. So 1309 is fixed. This one we're gonna fix it at, let's say ano ba to? Row 18, ito column O. So yan siya. Kaya ko lang naman finifix so that I can drag them. So mali yung finix ko pala. Dapat naka-fix siya kay Q, column Q. Ito fix kay row 20. So that when I drag them, yan. So we're gonna have the appropriate answers. Yun lang naman, shortcut lang. But if you want to do them one by one, you can. Kasi for example, 322.002, that's, and you can see it's 843 times 500 over 1309. Yun siya. That's how we got them. So these are the expected frequencies. So medyo mag-manual tayo. Then the chi-square test statistic. Chi-square test statistic right here is just the summation of OI minus EI quantity squared over EI, where O sub I are cells from the observed table, EIs are cells from the expected table. Okay, so gawa tayo ng O minus E quantity squared dito. Quantity squared all over E. Gawa tayo ng table na ganyan. Medyo manual talaga. So same table, but instead of observed and expected lang, that's gonna be O minus E quantity squared all over E. Diba? That's it. Yun yung hinihingi sa atin. Let's try fixing yung mga parentheses. So, still correct. We can drag them down and drag them sa right so that we'll have these cells. O minus E quantity squared. Let me check lang ha. Tama. Okay. So the answer will be the sum of all those things. So observed minus expected, quantity squared over expected, we sum all of them. Chi-square test statistic is equal to sum nilang lahat. So Excel still helps us with calculations. And so 365.887. That's the test statistic. Confirm natin mamaya using Statistica. Okay, so going back, we go to the critical value. This is a chi-square, pakita ko lang yung chi-square distribution. Chi-square distribution. So, it's not gonna be a perfect bell curve. Wait lang, may chat ata. Okay, sure. So, it's not gonna be a symmetric bell curve. It looks something like this, yung chi-square table. yung chi-square distribution. So what's the critical value? We're supposed to look at the chi-square table if you remember your previous stat classes. But actually we can use the Excel as well. So CHISC dist RT. So maniwala na lang muna kayo sa akin dito. Tapos ay ang X would be, wait lang, degrees of freedom would be, wait. Naalala ko lang. Columns minus 1 times row minus 1. Yun pala. Degrees of freedom is equal to columns minus 1 times row minus 1. Number of rows minus 1. So we have 2 rows, we have 2 columns, right? So our degrees of freedom will be 1 times 1. So degrees of freedom 1. So going back, CHISC inv RT. Yeah, so 0.05 yung alpha. You just use that function. We have so many chi-square functions. Ito yung tama for this case. CHISC inverse dot RT. So degrees of freedom, we computed it to be 1. So ito yun, critical value 3.84. So we don't need to use the chi-square table anymore. So since our test statistic is quite large as compared to our critical value, what do we do? Reject or not reject HO? Game, kayo naman. Ano bang number 6 and number 7 natin? Reject, do not reject? Or nahilo na ba? Anyone? So suppose this is our chi-square critical value. The cutoff is at 3.84 instead of 16.9. We reject. Kasi it's so far away dun sa right side ng distribution. So it's so far away within the rejection region or the critical region. So what happens is we reject HO. We say that survival rate. Take note ha, reject and do not reject HO. Walang accept HO. Do not reject. Rejecting HO means we conclude this. So the survival rate is not the same for males and females. Certain na tayo doon. Kasi reject HO siya. Survival rate significantly differs between males and females. Okay na? Ano? Questions dyan? Expected frequencies, lagay natin yung formula dito. I can send the Excel file later. Expected E sub I is equal to row total times column total all over grand total. So this is 466. Check natin na 466 times 809 all over 1309. So 288.002. This is what you're gonna expect if the proportion between the two is similar or the survival rate between males and females is similar. So guys, questions dyan? Okay na tayo dyan? Okay. Sige, so the remaining time, maybe we can use statistica. Tingnan natin kung madali. Kasi baka, let's say si Alain, maka ano ka naman ng statistica by the time ng exam, baka magamit mo rin. Nasaan na ba si statistica? Nasaan si statistica? Oh my God. Ayun. No na lang muna. Open. Medyo malag siya eh. Ito, Titanic. Saan ba si Titanic nakalagay? Titanic 1. Patay tayo dyan. Wala pala akong fresh copy ni Titanic. Titanic. CSV. Titanic. Open. Delimited. Take variable names from the first row of the file. Yeah. So we have this. Let's do both. First, the ANOVA. So saan siya nakalagay? Statistics, ANOVA, yan. May section talaga siya. One-way ANOVA lang. This is the only thing we're gonna use. So as you can see, we don't have to restructure the data for Statistica. So variables dependent would be, ano ba yung dependent variable natin? What varies across different categories? Age, right? So is age varying across different categories ng passenger class? So dependent variable age categorical factor P class. That's it. Okay na lang. All effects. So check natin. Let's check if we have the same answers. Please disregard the intercept row just in case hindi siya kasali. But let's look 37339.39, it's the same. 179,758.3, it's the same. So of course we're gonna arrive at the same answers. Ito yung p-value na important. The one for P class. Ibig sabihin, P class is a significant factor or P class contributes to the difference in ages or age differs significantly between passenger classes. So multiple ways of saying the same thing. But basta we reject the HO. Since we know HO and HA, right? So that's how you do that for Statistica. Sige, another thing. Tingnan natin ito. Ano pa ba meron natin dito? Summary. Wala yun. Ayan. Wait lang Profilers. Resids. Parang comps ata yan. Or means. Sige, try natin yung comps kasi we want to do comparisons, right? Sabi natin kanina ay which passenger class has significantly different ages. So let's do this. Ito ba yan? Ay, wait, mali ako. P class. Oh my God, ano ba yan? Sorry. Ito pala post-hoc. 2key HSD na lang. Familiar pa ba dun sa mga yun? Mga 2key HSD, 2key HSD na yun? 2key test. So it's not gonna be a part of the exam. Sige, just for illustration. Here, so these are the p-values. What the post-hoc test does is it compares pairwise na mga treatments or pairwise na age na passenger classes. So for example, this cell is the age for passenger class 1 significantly different from passenger class 2. So pag red siya, this is actually the p-value for that comparison. They're significantly different. Yun ang ibig sabihin niya. So what about the pair 1 and 3? So passenger class 1 and versus passenger class 3. They're also significantly different from each other. So what's interesting is 2 and 3, that pair. So apparently yung 29.5 and 24.8, statistically significant pa rin yung difference. Still gonna be statistically significant. Since it's still red, the p-value for that comparison is less than 0.05, yung alpha natin. So that's not gonna be a part of the test. That's called post-hoc test. Just to answer yung curiosity natin. Kasi our conclusion is at least one is different. Which among the three is different? Apparently, they're all different from each other. Okay. So last, the chi-square test. Paano nga ba si chi-square test? So the question is, the survival rate differ between sexes? So non-parametrics tayo. Non-parametrics. Observed versus expected chi-square. Yun, chi-square test siya. Observed versus expected chi-square. So the variables, hinahanap niya. Summary of observed versus expected frequency. So as you can see right here, we can't actually plug it in readily. We should have the table as well, yung ginawa natin kanina. These tables, observed frequencies and expected frequencies. So that a command apparently doesn't give us, doesn't help us right now. So let's look for another way to solve it. So close this analysis, basic statistics, tables and banners. Okay, specify tables. I want to get table na P class and sex. These are the two variables involved, right? So okay, and then nasa dito yung options. So specify tables. Okay. So, okay na yan. Ayan. So let's look at advanced and options. Ayan. Check this one. Pearson chi-square. Yan lang. So it's gonna highlight, if you check this, it's gonna highlight counts greater than 10. Let's uncheck that kasi counts are all greater than 10, right? So P class X, sige. So we have this. Nasaan na yung ano? Ala, binigo niya ako. Cross tabulation. Pearson chi-square. Sige, check natin lahat. Summary. Sige, all tables. Oh my God, binigaw ako ng statistika. Sorry. Dito yun eh. Ba't ayaw niya lumabas? Ayun. Ito yung kailangan nyo i-check, yung detailed two-way tables pala. By the way, for statistica kasi yung itsura niya or the way it looks, all these buttons, it's gonna give you outputs. So categorize histograms, outputs ulit siya. Right here, categorize histograms. So each button, just explore them on your own. But for the specific problem, we have to check Pearson's chi-square at least, at the very least. Kasi that's the result we're gonna interpret. Then advanced, detailed two-way tables pala yung gusto niya ngayon. It's been a long time since I used this. So detailed two-way tables, for all tables, let's check that. So here, Pearson's chi-square to 20.37878. P-value is very low, 0.004. Sandali nga, actually nagkamali ako ng variable. Dapat pala survival, no? Sorry. So, let me go back. Specify the tables, summary tables. Let's just close this. Gawa tayo ng bago. Start new. Tables and banners again. The variables are gonna be survived and sex pala. Sorry. So, okay. Let's look at the options. Sige, okay na yan. So options, chi-square, advanced, detailed two-way tables. So here, eto pala yung tama. So chi-square test statistic is 365.887. Are we correct earlier? Yes, we are correct. 365.887 is the test statistic. And then p-value is going to be very low. We don't have the critical value na dito. We go straight sa p-value. P-value of this much means reject HO. So we arrive at the same conclusion. That's all of the time. Using the critical value approach, what we did sa Excel, and the p-value approach, what we did with Statistica. So ano ba? Kamusta kayo? Okay pa? Kuha siya?
Excuse me, on Excel, how did we find the critical value?
Sige, the critical value, I think you were away. Right here. So basically from Stat 101, from senior high stat, we're gonna use the chi-square table. Most schools do that. But right here, we have this function, chi-square chisk.inv.rt. That specific function where you just input the alpha and the degrees of freedom one. We arrive at the critical value.
Yes. All right. That's easy.
Degrees of freedom is columns, number of columns minus 1 times number of rows minus 1. So 2 minus 1 times 2 minus 1. 3.84 yung critical value. So okay na?
Sir, could you repeat that again?
Which one?
Yeah, degrees of freedom.
A number of columns. We have 2 columns minus 1, that's 1. Number of rows, we have 2, so minus 1, that's 1. Multiply them, that's 1. So yun siya. Degrees of freedom.
Okay. Sorry, my bad.
Ito naman yung it guides you, the Excel function. So probability, that's alpha. Degrees of freedom, we compute it as 1. 3.84. So that's when you're gonna use Excel lang. It's I think it's a lot easier using Statistica for this particular problem. So ayos na. Sige, last one. Just finish the meeting. I think it's still part of the videos, STT203A. Yes, and correlation and regression. So this is quick kasi I know it's easy sa Excel, it's easy sa Statistica. So correlation analysis, it's being done when you have two quantitative variables. You want to see if there's a relationship. For example, let's create a simple example right here. These are your grades, Stat 201, Stat 203. Suppose you're done. See person A, person B, person C, D, E, F. So grade nyo, ano ba maganda? 87. Sige, random tayo. Random between, pasado lahat, 75 to 100. I'm generating data, simulating data. Sige, for Stat 203, medyo nahirapan daw kayo. Run between 65 and 93. Okay, so these are the simulated na grades. So suppose I want to know if these two are correlated. Did those who score high in Stat 201 also score high or got high grades for Stat 203? So what do we do is make use of correlations. So some steps lang for correlations. I think scatter plots, we have already discussed them as well. Let's use age and fair. Are age and fair correlated with each other? They're the only quantitative variables we have. So we're stuck with them. So first off, what we can do is to summarize them using scatter plots. So this is the scatter plot. Medyo madumi siya. But what can you observe? Is there a pattern? X-axis is age, y-axis is fair. Do older people tend to pay more? Or do younger people tend to pay more? Can you see any pattern or is there no pattern? So anyone, visual assessment. Fair and age. Palagay nyo. Sige, kahit paki-chat na lang kung ayaw magsalita. Hello? May trend ba? Or no pattern? What do you think?
No pattern.
See, no pattern. So actually there's no obvious correct answer here. But okay, no pattern. So that's visual assessment lang. So from the scatter plot. So we do that. We can do that. Scatter plot. So the next thing we can do is to answer, is there really a relationship? Sino yung sumagot? Pangalan mo?
Dallas.
Ano?
Gian.
Gian, right? Ayan. Gian answered, there's no relationship. So we confirm. Of course, this is still part of Stat 201, still part of the video. So hopefully this is clear. We have the correlation coefficient. So correlation coefficient, it's the quantitative measure of linear relationship between two variables. So correlation. The correlation between age and fair, it's really easy sa Excel. It's the correl function. Correlation for age and fair. We arrive at the answer, 0.178. So how do we interpret this? The Pearson's R, as it's called as well, Pearson's R or correlation coefficient, it's a number ranging from -1 to 1, where the sign is interpreted as, if it's negative, they have an inverse relationship. Meaning, if one goes up, the other one goes down. That's when Pearson's R, this number is negative. So when it's positive, the tendency is as one goes up, the other one goes up as well. So in this case, we have a direct linear relationship since it's positive. However, we have to take note of the magnitude as well. So the magnitude of Pearson's R, when it's closer to 0, it means that there's no relationship between two variables. When it's closer to 1, there's a stronger relationship. So same with what Gian has said, this is quite weak. 0.178 na correlation. It's very near 0. So we have a very weak correlation, almost none, between age and fair. And you won't get exactly 0 naman for this. You won't get exactly 0 for Pearson's R, the correlation coefficient. So that's enough to describe. There's a weak, very weak relationship between age and fair. And the relationship is direct. As one goes up, the other one goes up as well. So clear naman. Sige, so meron silang correlation. It's quite weak. So the next step, the next logical step after assessing correlation is, suppose the correlation is quite high. Kunwari 0.9. This is ano lang, suppose lang. If the correlation is quite high, maybe we can predict fares from age, right? Pwede natin gawin yun. If we know the age of a passenger, we can predict the fare that he or she will be given if the correlation is high. And actually, we can do that even if the correlation is low. It's not just it's just not gonna be logical. Kasi nga, hindi naman sila related. Why predict the other using the other one, right? But just for the sake of illustration lang, let's do it. Let's create a function predicting fare from age. Okay. So sige, so how do we do that? Again, data analysis tool pack. It's the so-called linear regression, simple linear regression. So y is the dependent variable, the one being predicted. X is the predictor. That's gonna be age. Wait lang. In yung structure natin, right, what I mentioned earlier, we want to predict fare from age. So that's F. We have labels. Okay then. Oh my God. Alam mo yung problem ni Excel? Since we have observations such as this one, age na si Bauman Mr. John, he doesn't have an age but he has a record of the fare. Excel doesn't want to compute na agad. So it's a problem. So I'm not gonna give you missing data when it comes to the exam. So let's simulate data yet again. Let's use another example. STAT201A. Gets naman ba't ako nag-stop ha? So let's just use let's say 10 different people. H, I, J. Kaya namang mag-simulate. So rand between 65 to 100. Sige, maglagay ako dito ng fancy function. Is equal to this one times 0.65 plus 0.4 times 82. Wait lang ha. Rand between 0 to 10. So simulation lang what I did. Round them up. This is 86, 82, 86, 83, 96, 87, 85, 94, 98, 92. So those are the grades for students A to J for Stat 201 and Stat 203. So let's see. Let's repeat everything. Correl, what's the correlation between Stat 201 grades and Stat 203 grades? So on the spot, we're doing this. And so it's quite high. That's the reason why I did that complicated formula. I want to simulate a data set which has a high correlation. So here, it's going to be 0.879211. So clearly, 203 and 201 grades are highly correlated, right? And it's a direct linear relationship, meaning when the other one goes up, the other one goes up as well. Meaning generally, those who get high sa Stat 201 get high grades for Stat 203 too. Okay? So now, it's logical to predict Stat 203 from Stat 201 grades. Since Stat 201 grades come before Stat 203, right? So what we can do is to create a regression equation. So data, regression. We want to predict Stat 203 from Stat 201 grades. Labels, check. Yan. So, ayan. Here, we want to interpret these results. How do we interpret these results? These two are the most important na components for now, as well as R square. So these highlighted cells. If you want, I can send you this Excel file later, so that you if you want to review them. So first off, suppose we want to predict Stat 203 from Stat 201 grades. These are the coefficients, or the so-called regression coefficients, meaning we want to predict Y, Stat 203. Then the functional relationship is going to be 39.95 plus 0.61, times Stat 201. Ganon siya. So we have successfully built a functional relationship, a function which predicts Stat 203 from Stat 201 grades. So this is it. Okay, so copy natin. However, the problem is, let's see ha. Let's try predicting. Suppose we don't know that A will get an 86 from Stat 203. So that's going to be 39.95. If we're going to use the regression formula, 0.61 times Stat 201. Kuha pa naman ako. So we're going to arrive at these answers. There's always going to be a discrepancy. These are the predicted values. So predicted Stat 203. Ito yung Stat 203 grades. So yun. Ang gusto ko lang i-point out, it's not gonna be perfect. This model, it's not gonna be perfect. It will yield estimates for Stat 203 grades, but it's not gonna be perfect. So how do we assess yung parang perfectness niya? How good is that model? We call it a model ha. How good is that model in predicting Stat 203 grades? We interpret the R square. So yan, kaya naka-highlight silang tatlo. These are the coefficients. This is the measure of goodness of fit. So the R square is interpreted as, we convert it into a percentage, 77.30%. 77.30% of the total variation in STT203A grades can be explained by STT201A grades. Or basically, most of the variation in Stat 203 grades, it can be explained by your Stat 201 grades. Most kasi it's greater than 50%. In fact, it's greater than 70%. In statistics, in practice, 70% is our cutoff for saying that the model is good. So our model is a good model. This equation, it's good for predicting Stat 203 grades. Why? Because R squared is quite high. It's greater than the cutoff of 70. Let's keep it that way for now. So ano ba? Over na ba? O okay pa?
Excuse me.
Yes?
So we got the regression statistics by data analysis regression. Which data did we use? X and Y, right?
X and Y. Here. Y will be the one you're gonna predict. So
Yes.
predict this. Ito ay predictor.
Yes. Yes.
Okay. So clear na, okay yun.
Yeah.
So summary lang ha. ANOVA, okay. Chi-square, okay. Correlation and regression, okay na rin. So last part, we'll be doing it using STATISTICA. So STATISTICA, I think it's powerful enough that it's gonna disregard the problems we have encountered earlier. Remember, it doesn't want, Excel doesn't want these missing cells. So I think STATISTICA can manage to ignore them. By ignore, I mean just deleting observation 16 altogether. That's how it approaches that problem. So multiple regression, that's what we're gonna use. Variables, the dependent one is the one being predicted, so that's fair. Independent variable, we want to predict it using age. And so ito yung results niya. As usual, the intercept is 16.01. Nasan yung ano? Sige na, summary regression results. Ito rin naman siya. So 16.01 plus 0.69 times age. That's how you interpret them. Same with the table earlier, di ba, sa Excel table. Different example lang ito. Ito yung fair and age example from Titanic. So 16.01, 16.02 plus 0.69 times age. That will be our regression equation. Now, we want to answer, is it a good model? Is it a good predictor? Look at R squared right here at the top. So it's a bad predictor. It's a bad model. It's just 3%. 3% of the total variation in fair can be explained by age, which is clearly not enough, right? So we don't want to predict fair using age. So it's a bad model, contrary to our STAT203 model right here. So yun lang. Summary again, ANOVA, kaya gawin, chi-square, you will do it manually, unfortunately, if you're using Excel. But for Statistica, it's simple. For regression, you're just gonna have to learn how to interpret regression coefficients as well as R-square. Baka masyadong mabilis. Tanong ba? Questions, guys?
Excuse me, how do you suggest we prepare for the quiz, even though we can use our references and calculator and whatever?
Ano ba ito? You can play with the Titanic dataset. Actually, that's the best way you can prepare for the exam. Kasi that's exactly what you're gonna do. You're gonna be given a dataset. You're gonna be asked some questions. So suppose you want to ask a question. Does fair vary significantly different across different places where they embarked, right? So these are the questions that you just asked. Diba na remember your reporting? You have some questions that you ask. Confirm them using hypothesis tests.
Yeah, for example, is there any difference between like fair and place embarked?
Fair across different place embarked, right?
Yes.
So
in that case, that would be chi-square test, right? Because you have embarked, right, which is qualitative.
But fair is quantitative kasi. So you're gonna have to take the averages, right? Average of fair sa S, average fair for C, average fair for Q.
Yeah.
So it's not gonna be a chi-square test, right?
So it's gonna be different tests. It's going to be like we're going to use the difference. Let's say our H now for that case would be MS equals MC equals MQ. Yeah. Something like that.
We only have a few options naman eh. So t-test for 1 mean, basically we reduce them. T-test for 2 means ANOVA, chi-square, correlation and regression. You only have these options. So which among them? Diba ANOVA? Kasi we're comparing, as you've mentioned, means across different place embarked.
Yes.
So ANOVA siya.
ANOVA.
So,
and the ANOVA, we can do it sa Excel, right?
Yes. Everything you can do naman sa Excel. We have
Data analysis. We don't need to do manual for that, right?
Yes,
ANOVA.
yes. Chi-square lang. Chi-square in Excel. That's you're gonna involve manual calculations like this. See, I received a question right here. Anong type ng question? Yung type ng question is sige, meron na ipapakita sa inyo. Nagpa-exam ako earlier this morning. Nasaan na yung DLSU? Linear models. This is I think you're gonna take this subject end of this year, your 6th term. So this is my long exam. So something like this, expect something like this. This one, number 2. So I gave them an Excel file. Earlier. And then I listed some tasks, perform them. Yung submissions nila are, let's see. Download. Sino bang malupit dito? Ito pala, si Noriel na lang. Ay, ayoko nung hindi pala yung kanya. Wait lang ha, pakita ko lang sa inyo. Expect these types of outputs. So here, so part 2. Ayan. So they provided outputs from, they used R, you're gonna use Excel. So something like this. Expect these types of questions. Guided siya bale. Just provide me the outputs. If I'm asking for a graph, give me a graph. If I'm asking for a hypothesis test, conduct a hypothesis test. So kaya nga, my answer to Javi kanina, how do we practice? I think this is the best way. Use the Titanic dataset. You ask some more questions. You answer the questions that you asked from the reporting.
Or we can just play around, right, with the data and see what happens. Yep.
Or if you're really into it, you can download any other dataset. You can play with them. Clear naman si Polo,
Yeah,
no?
because the Titanic dataset, you have missing gaps like the age. You have missing gaps, like there's no fair here, there's no age.
And so, but you're gonna encounter that in real life. A lot of those missing data. But at the start of our meetings naman, first session natin, di ba? How do we deal with missing data for now? We can delete them, right? Or for example, something like this, you don't want to see this number, you can round them off to 1. Those are the ways we can deal with dirty data.
Yeah, you mentioned that during the quiz, you won't, just for the quiz, you won't be giving us like a data set with missing data, right?
Sige, okay na, ganun na lang. So that
Yeah, I'm asking you because he said, I'm clarifying because he said at the start to us.
Sige. I'm gonna do that. No missing data for the exam para it's gonna be a bit easier.
Right.
Kasi nga, some of you don't have Excel. Missing data is a problem for Excel. Diba yung regression didn't work earlier. So yun, I won't give you any missing data. Okay na. So if you don't have any questions, we're done for today. See you sometime later. Kailan ba yung next meeting natin? It will be, I think, December 9.
9, because it's 7 we have the quiz.
Yes. So for December 9, by the way, I hope you have installed R already. We're gonna start with R on December 9. Okay.
Right.
So yun lang. If you don't have any questions, you may go.
Thank you,
Good luck.
sir.
Good luck